this year we decided we're going to try to pick up the hatches off the ground and be able to place them everywhere possible, including on all 3 slots on the rocket, as well as be able to pick up the ball and get it in every slot, including all 3 slots on the rocket. And we're going to attempt to get on the 2nd level of the platform, and after we get that kind of worked out, we're going to go and try to attempt to get on the 3rd level. So we are using a lift mechanism using 4 parallel bars to hold it steady and hold the front plate for our pickup mechanism in tandem with our back bar, allowing us to kind of have a sturdy base for our pickup mechanism. Initially, we were going to use 2 parallel axes with 4 wheels on them, and then we went to a straight bar over top because it seemed to pick it up and grip it a little bit better. It seems a little bit more consistent. So we've got the motor that spins our overtop wheels to pick up the bar with a piece of Lexan on the underneath side with Velcro that holds the cover really well. You could shake this just about as much as you want and it's not going to fall off. That way we can tip it however we want to, we can set it, and we're going to have a piston base somewhere in here to push it off as we attach it to the rocket or the cargo. Ta-da.
So one of the things we were prototyping today was the intake. We had 2 ideas, either an over-the-top intake or a side intake. We identified several problems with the side intake. The first being, if we hit it off angle, the ball will be sent flying and not be pulled in. Whereas with the over-the-top intake, as soon as we make contact with the ball, it will be pulled in and we will have control. The other issue with the side intake is that each wheel requires its own motor, which adds weight. Whereas the over-the-top intake requires a single motor. Oh yeah. Okay, let's go to the side.
We're on high speed.
No. Jordan, were you holding that down?
Yep.
Jordan, were you holding that down? Don't hold it. Just let go of it. Oh yeah, that works really well. Let's go to the side. Yeah, we're not gonna have any problem with that.
Hi, my name is Cami Kudrina, here with the zookeepers here in Columbia, Missouri, and this is just in. As you guys may have read in the game manual, the balls are not made consistently. For example, the skin on the ball is thicker in some areas than others, so if you hold it up to the light, the dark spots are where it is thicker than the light spots. So, whenever we were looking at this ball, and we filled it up whenever we first got the kit of parts, we said to ourselves, hey, that's enough air. Well, after further measurements, we discovered that our ball was only at an 11-inch diameter. I know. So, you have to be sure to measure your game pieces. It took us a few times of measuring and pumping up the ball before we got it to the full 13-inch diameter suggested by the game manual. This is just a PSA to let you know you do not just have to measure your robot dimensions, but you also need to remember to measure your game piece dimensions, so when you get to your regional or district event, you know what you are up against. Thank you.
So we've got most of the CAD finished. We've designed our intake. It has a wrist on it, so it rotates back 90 degrees, and it has this flat plate. So this plate, we're planning on putting Velcro on it, so we can drive up to the feeder station and Velcro onto the disc, the catch. Hatch. We're gonna Velcro onto the hatch. And then the arms just lift up and let us deliver it at whatever height we need. Now, if one of the hatches falls on the ground, this rotates flat. We drop our arms, and the Velcro picks it up. Let's see here. We have made sure that the arms, the whole entire mechanism stays within 30 inches throughout the entire movement. This line right here is the center of the top goal on the rocket, and we can go right up there and place the ball. In order to rotate the wrist 90 degrees, we're going to use a pneumatic piston. And so it'll go from this up position is then down 90 degrees to the down position. Since we're using a pneumatic piston, there won't be any in between. So whenever we're in the up position, the hatch will be Velcroed to here. So in order to get rid of or disconnect the Velcro, there's going to be a pneumatic piston that goes through the center hole and pushes the hatch off. It'll fit right through the center, right here. In order to climb, our plan is to shoot. We're going to go for the second one right now. So we're going to put a cylinder in each corner on the back and have it push down so that we can drive up and get a hold of the ledge, and then raise our pneumatic cylinders and drive the rest of the way up. The tank treads that we have on our Raptor track that was graciously provided by Andy Mark will allow us to continuously grip the edge and pull ourselves all the way up, whereas wheels would get high centered.
So over here, we have our prototype intake, which we messed with a little bit earlier with a drill and then practiced pulling the ball into the intake, and it actually worked pretty well. We had a few options of wheels that we could have used to pull in the ball. These blue flywheels that we worked with were actually better than the green wheels. We saw that actually our blue wheels are a little bit more worn because of previous use, but the green wheels are just a little bit more slick, and they have this kind of shiny coating on them, and they don't seem to grip as well as these rougher blue ones. But we actually ended up going with these Omni wheels, which actually have pretty similar grip to the blue or green ones, whichever one you might see, but these actually have a better way of filtering the ball in, so that is more easily centered within the intake mechanism, so we don't have to worry about it bouncing off to the side or having any other misalignment issues.
It's about 8:30 and we just finished for today. We'll keep you guys updated with more information tomorrow. Thanks for watching.